Hello students. So today we are going to study about Kirchhoff's law. Kirchhoff's law is nothing but the extended version of Ohm's law to solve complicated circuits. So using Kirchhoff's law we can find current in any part of a complicated circuit using these laws. Actually Kirchhoff's law consists of two laws which we are going to study today, but before studying these laws first we have to define a few terms. These terms are, first term is electric network. To define Kirchhoff's law we should know all these terms. Second is junction. Third, loop, or we also called it as mesh. And the last one is branch. So सबसे पहले हमें ये समझना है कि what are all these terms. If we know about these terms, only then we can define Kirchhoff's law clearly. So first term, electric network. What is electric network? This term is used for a complicated system of electrical conductors. Means if we have a complicated circuit containing electrical conductors, then we called it as electric network. So electric network is, it is used for a complicated system of electrical conductors. Next term that we should know is junction. What is a junction? So junction is any point in an electric circuit or in an electric network where two or more conductors join together. When we have an electric network, suppose we have an electric network like this. Right? So this is a certain electric network. It can be any electric network. So for an example, I take this electric network. Now in this electric network, the points where two or more conductors are joined are called junction, like this. This is the point where these conductors are joined, so this is called a junction, right? So what is a junction? Junction is any point in an electric circuit where two or more conductors are joined together, right? Junction is a point where two or more conductors are joined together in an electric circuit or in an electric network. Now the third term is a loop or a mesh. What is a loop? So loop is any closed conducting path in an electric network. For example, in this network, this is an electric path which is closed. Means ये आपका एक closed conducting path है, right? ये भी आपका एक closed conducting path है. So this closed conducting path in an electric network is called a loop or a mesh. So what we can write, a loop or a mesh is any closed conducting path, any closed conducting path in an electric network is called loop or a mesh, right? The next term is branch. So what is a branch? A branch is any part of the network that lies between two जंक्शंस। दो जंक्शंस के बीच में जो भी path lie करेगा, that is called a branch. Like in this circuit, this is a junction, this is also a junction, and between these two junctions this branch exists, right? This arm exists. So इस arm को या इस part को हम circuit के बोलेंगे branch. So branch is what? Branch is the part of the network that lies between two junctions. Branch is any part of the network that lies between two junctions. This is called branch. So we are clear about the four terms. First, electric network. Any complicated circuit or a system of electric conductors is called electric network. Junction, any point in an electric circuit where two or more conductors are joined together is called junction. Loop, any closed conducting path in any electric network is called loop or mesh. Branch, part between any two junctions, दो junctions के बीच का जो भी part होगा, that is called a branch. Now after these terms we are ready to understand Kirchhoff's law. So Kirchhoff's law consists of two different laws. We are starting with the Kirchhoff's first law. Kirchhoff's first law is also known as junction rule. First, let's see its statement and then we will understand it. So, statement of Kirchhoff's first law is that in an electrical circuit, the algebraic sum of currents in an electric circuit, the algebraic sum of currents at any junction is 0. Right? Now this is important. The algebraic sum of currents at any junction is 0, or we can also write it as the sum of current entering a junction is equal to the sum of currents leaving the junction, or we can also state it as sum of currents entering the junction is equal to the sum of leaving currents at the junction, right? So जितना junction पे current enter हो रहा है that will be equal to the जितना current junction से निकल रहा है. If we talk mathematically, then this law can be expressed as summation I is equal to 0. Means total of the currents, or we can say algebraic sum of the currents at any junction is 0, or the sum of currents entering the junction or sum of currents leaving the junction will be equal. For applying Kirchhoff's first law in any electric network, there is a sign convention that we have to know. So the sign convention for applying junction rule is, first point in the sign convention is the currents flowing towards the junction are taken as positive. That means current towards the junction are positive, and the second is current flowing away from the junction are negative. Now these are the two sign conventions which we have to follow while applying junction rule or while using Kirchhoff's law in any electric network. So we can understand this by considering an example. Suppose in any electric network I have a junction, this, and at this junction there are four branches connected to it having currents I1, I2, I3 and I4 such that I1, I2, I3 and I4. Now, among these four currents, I1 and I2 are traveling towards the junction while I3 and I4 are traveling away from the junction. So now we want to apply junction rule. In this section of the electric network or at this junction. So according to the Kirchhoff's law, the algebraic sum of the currents at any junction is 0. So what we are going to do, we are going to take algebraic sum of all these currents at the junction and put it equal to 0. So this algebraic summation I consists of the algebraic sum of I1, I2, I3 and I4. Now when we are taking algebraic sum, we have to consider the signs as per the sign convention. So according to sign convention, current towards the junction are positive. That means I1 and I2 means those currents which are flowing towards the junction are positive, while those who are flowing away from the junction, that is I3 and I4, are negative. So we can write it as I1 plus I2 minus I3 minus I4 is equal to 0, or we can rearrange it to get I1 plus I2 is equal to I3 plus I4, and this form that we get by rearranging shows that sum of currents flowing towards the junction is equal to the sum of currents flowing away from the junction, or we can say incoming current or the current coming towards the junction, incoming current is equal to the current going away from the junction, or we can say outgoing current. Incoming current is equal to outgoing current. This is the required first law of Kirchhoff's laws, and we called it as Kirchhoff's current law. Sometimes we can find it written as KCL, Kirchhoff's current law, or we can write it as Kirchhoff's first law or junction rule. Or one more thing that we have to note is this law is based on the law of conservation of charge. This is based on law of conservation of charge. Why this is so? Because when currents in a circuit are steady or when currents in a circuit are not changing, are equal, then charges are not accumulating or originating at any point of the circuit. Means कोई भी नया charge वहाँ पे originate नहीं हो रहा है, but it flows towards the junction or away from the junction. That means the charge flowing towards the junction in any time interval is equal to the charge flowing away from the junction in the same time interval. Why we are saying that it is based on law of conservation of charge? Because in the whole process no charge is accumulating or originating at any point of the circuit. So जो भी charge flow कर रहा है towards the junction in any time interval, it must be equal to the charge flowing away from the junction in that same time interval. So we can say that the above law or Kirchhoff's current law is based on the law of conservation of charge. This was all about the Kirchhoff's first law, or we can say Kirchhoff's current law. The Kirchhoff's current law states that incoming current is equal to outgoing current, or algebraic sum of the currents at any junction is 0, or current traveling towards the junction must be equal to the current flowing away from the junction. All these statements are showing Kirchhoff's current law. Now moving to the Kirchhoff's second law, that is known as Kirchhoff's second law, or sometimes we called it as loop rule. Kirchhoff's second law, or we can write it as loop rule. This one is the second law of Kirchhoff. Now, the statement for this second law is, around any closed loop of a network. We have an electric network, and around any closed loop of a network, the algebraic sum of changes in potential must be 0. Here we have to know, we are not saying potential, we are saying changes in potential must be 0. Let me write it. Around any closed loop of a network, the algebraic sum of changes in the potential, the algebraic sum of changes in the potential must be 0. Right? Changes in the potential का sum हमें देखना है. We are not saying potential, we are saying changes in potential must be 0. Or we can also write it as the algebraic sum of EMFs in any loop of a circuit is equal to the sum of products of currents and resistances in it. Now we are going to understand it step by step. What we are saying, the algebraic sum of EMFs in any loop of a circuit is equal to the sum of products of currents and resistances in it. Alright, so what it is saying, the algebraic sum of EMFs means एक साइड तो है आपके पास algebraic sum सारे EMFs का किसी भी loop में is equal to the sum of products of currents means I and resistances means I into R के जो product आएगा IR उसके sum के equal. Mathematically we can write these two statements as so first I am writing about the first statement. First statement क्या कह रहा है हमें, around any closed loop of a network the algebraic sum of changes in the potential must be 0. The algebraic sum, so we are taking summation, the algebraic sum of changes in the potential, delta is representing changes in the potential must be 0. That means summation delta V must be 0. Or from second statement we can write it as the algebraic sum of EMFs means summation epsilon. The algebraic sum of EMFs must be equal to the sum of products of currents and resistances means summation I R. So these are the statements that show these laws mathematically, right? So this was the Kirchhoff's second law. Kirchhoff's second law, right? So now again for applying Kirchhoff's second law practically we have some sign convention just as we have in the first law. So we are going to study that first. Alright, so let's start with the sign convention for applying loop rule. So the very first point in this sign convention is that we are free to take any direction as the direction of travel. Means it's our choice whether we are going in a circuit clockwise or anti-clockwise, but we have to maintain that direction throughout the circuit. So the first point is we can take any direction. Now from direction it means clockwise or anti-clockwise as the direction of travel in the loop, right? The very first point that we have to see in any circuit कि हम clockwise motion देख रहे हैं या anti clockwise, that we have to decide on our own. Now coming to the second point, second point is we have to check the EMF or the cells connected. If the EMF of a cell is epsilon and the in the circuit it is connected like this. Now there can be two situations. The cell connected, द सेल जो भी हमारे पास कनेक्टेड है उसका डायरेक्शन या उसके टर्मिनल्स और हमारे मोशन के डायरेक्शन के दो कंडीशंस पॉसिबल हैं हमारे पास कि या तो मोशन हो रहा होगा फ्रॉम नेगेटिव टर्मिनल टू पॉजिटिव टर्मिनल, और द सेकेंड कंडीशन इज कि मोशन हो रहा होगा फ्रॉम पॉजिटिव टू नेगेटिव टर्मिनल, राइट? और वी कैन see it as, suppose I have this cell connected in a circuit like this. Now someone is taking clockwise motion while the other person is taking anti-clockwise motion. So one person is going like this while the other person is going like this, right? So in this case the motion is from negative to positive, while in this case the motion is from positive to negative. So we have to check this whether we are going from negative to positive or from positive to negative. Then comes the sign convention. If direction of travel is from negative to positive, means in this case if direction is from negative to positive, then the EMF of the electrolyte is taken as positive, or the EMF of a cell is taken as positive. Like in this case we are going to take EMF as positive, while in this case we are going to take V is equal to minus epsilon. So what we have to remember, if direction of travel is from negative terminal to positive terminal, then EMF of cell is taken as positive and vice versa. मीन्स अगर ट्रैवल का डायरेक्शन नेगेटिव से पॉजिटिव है देन वी आर गोइंग टू टेक प्लस एप्सिलॉन, और अगर पॉजिटिव से नेगेटिव होगा देन वी आर गोइंग टू टेक माइनस एप्सिलॉन और नेगेटिव ईएमएफ, राइट? नाउ कमिंग टू द नेक्स्ट पॉइंट, थर्ड, this point is about the product IR. So here also two cases can be possible. Suppose this is the resistance connected, capital R, right, and current flowing in it like this in this direction. Now if one is taking clockwise and other is taking anti-clockwise direction, so direction of travel, if first one is going like this then other must be going like this. So here also two cases arises, that in case one, the motion, the direction of travel that we considered is same as that of the flow of current, while in the second case the direction of travel is opposite to that of the current. Now here comes the sign convention. Sign convention says that if the resistor or if the current travel in the same direction, if the current travel in the same direction, then the product IR is taken as positive, while if the current travel in the opposite direction, then the product IR is taken as negative. Means in this case where we have same directions, we are going to take V is equal to plus IR, while in this case where we are having opposite direction, we are going to take V is equal to minus IR. So if the direction of current and the direction that we consider are same, then the product of current and resistance is taken as positive. Means same direction, we are going to have positive IR, and opposite direction, then we are going to have negative IR, right? So this was all about the sign convention while applying second Kirchhoff's law, or we can say loop rule. Now again, here is a point to note that this law is based on the law of conservation of energy. This is based on law of conservation of energy. Like the first law is based on conservation of charge, this second Kirchhoff's law is based on law of conservation of energy, because the electrostatic force is a conservative force, and so the work done by it along any closed path must be zero, right? So this is all because of the flow of charge, and electrostatic force must be acting there. So the electrostatic force is a conservative force, and the work done by it along any closed path, because we are having closed loop, so along any closed path must be zero. That's why the energy remains conserved. So we say that the Kirchhoffs second law, or Kirchhoffs loop law, or we can also say it as Kirchhoffs voltage law. Sometimes it is also known as Kirchhoffs voltage law, is based on the fact of law of conservation of energy, because electrostatic force is acting there, and these forces are conservative force, and work done because of these forces along any closed paths are zero, so energy remains conserved. So this was all about the Kirchhoff's laws. Law number 1, Kirchhoff's current law, or we can say Kirchhoff's junction rule, and the second Kirchhoff's law is the Kirchhoff's loop rule or Kirchhoff's voltage law. So in our next video we will be solving some questions, numericals, by applying these Kirchhoff's laws. Till then, keep studying and stay safe. Thank you.